Okay, here are the 7.4 rational equation notes, page 3. This page is entirely examples. So what I would do is pause now, work through these, get the ones done that you can, check with the answer key, and then come back and fill in any of the ones that you're struggling with. Okay, so if you paused and you're back, or if you never went away, that is fine. I am going to start, and because I have limited space, I am not going to multiply by one number at a time. I'm going to go ahead and find our least common denominator here. I've got a 5 and an 8, which means my least common denominator is 40. So I'm multiplying on both sides by 40. And I am going to write out this middle step. I get 40x over 5 minus 40x over 8 equals 240. 5 goes into that 48 times. I have 8 times x here. 8 goes into 40 5 times. I have 3x equals 240. When I divide both sides by 3, I get x equals 80. I'm going to go ahead and change color and see if I can keep this from getting confusing, because I obviously write too big. Let's see if I can blow this up and make it a little better. Okay, so I have a 4, a 7, and an x, which means 4 times 7 is 28 times x. I am multiplying everything on both sides by 28x. And again, I'm going to go ahead and include that middle step, 28x over 4 when I multiply here, plus 28x over 7 when I distribute here, and I get 28x over x. I get the 4's cancel. I got the 7's canceling. I got the x's canceling. I got 11x equals 28. Divide both sides by 11. And x equals 28 over 11. I cannot reduce that. I'm going to leave it like that. Absolutely no reason to convert that to a decimal. This top right one, I've got an x and an x squared. So my least common denominator is x squared. And if you're struggling with the least common denominators, pick the biggest number to multiply by. X squared times 1 gives me x squared. I got x squared times 1 over x gives me x squared over x. And then I got 12x squared over x squared. I can cancel the x squareds here. I can cancel one of the x's here. Now I'm going to move everything to the same side. And I'm going to factor. Four and 3 plus 4 minus 3. X equals 4. Sorry, x equals negative 4. X equals positive 3. Now, I skipped something in the last one because I just did. Okay. If I take a look at my original equation up here, I know that x cannot be 0. Neither of my answers are 0, so I'm okay. Same thing over here. X cannot be 0. It would make this one undefined. We're okay there. 28 over 11 is not 0. But you definitely want to check and make sure you have not come up with a solution that you cannot use. Okay. Next one down, in the denominator, I got a 2x, a 16, and an x. So the 16 will take care of the 16 in the 2 part. And then we need an x to take care of that random x and the x in the 2x. Okay. Now again, because I should probably be in the habit of doing this at the beginning, x cannot be 0 because I have a 2x and an x in my denominator. Plugging 0 in on either of those are going to make those equations, or sorry, that part of the expression undefined. Dun, dun, dun. So now I am just physically writing out 16x times everything I have. Remember, when I multiply by 16x, I'm really multiplying by 16x over 1. So the 16x only gets multiplied in the numerator. It does not get multiplied numerator and denominator. Be careful. I can cancel the 2x and the 16x. I get 8 times x plus 2. Plus, I can cancel the 16s. I get an x squared. And I can cancel the x's, and I get a 16. I get 8x plus 16 plus x squared equals 16. I am going to move everything to one side. Subtract 16 from both sides. And then I'm going to factor. I get x equals 0, and I get x equals negative 8. Okay, now, if we take a look at what we started with up here, that was the fact that x cannot be 0. So that solution doesn't count. And I'm left with just this one, x equals negative 8. Again, we could plug that into the equation, make sure that it works. Right now I got limited space. Okay. Let's take a look at this one in the middle. I've got 1 over x plus 4 minus 7 over x minus 4 equals 4 over x squared minus 16, which I know factors into x minus 4x plus 4. Is it possible that all 3 denominators have different binomials and you get something big and ugly when you multiply it out? Yes. Yes, it is. Not for the purpose of this exercise, though. Okay. So we know that x cannot be 4 and x cannot be negative 4. Both of those would give us a 0 in the denominator somewhere. So we're going to multiply everything by x minus 4 times x plus 4. X minus 4 times 1 over x plus 4. I could even put the 1 in here. 7 times x minus 4 times x plus 4, all over x minus 4. And I got 4 times x minus 4 times x plus 4, all over x minus 4 times x plus 4. We cancel the pieces that we have in common. And work with what we have left. X minus 7x minus 6x minus 32 equals 4. I get minus 6x equals 36. And I get x equals negative 6. Not one of my no-nos, so we're good. Again, this denominator factors into my two pieces. Not going to make life super difficult right now. I am going to go through and multiply though. I find that when I leave this step out, I tend to make mistakes. And we are going to cancel, oops, what we can. I get x plus 5 plus 4x plus 28 equals negative 2. 5x plus 33 equals negative 2. 5x equals negative 35. X equals negative 7. Now, notice I got super excited to do this one. And so I did not take a look at what I cannot use. So x plus 7, negative 7 would make that 0, and I got an x plus 5. X cannot be negative 7, which is our solution. So here we have no solutions. Just going to go ahead and do these last two examples, and then I will, we can do the literal equations in a separate recording. Maybe we'll just cram them all in here. Anyway, I'm talking to myself. Hopefully you're seeing the pattern at this point. So I got 3 times x minus 3 times x minus 5. Okay, let's back up and do what I forgot to do last time. X minus 3, so I know x cannot be 3. X minus 5, x cannot be 5. Before I get ahead of myself. Sometimes we get super excited about actually getting an answer that we forget to check for any restrictions that we may have on our domain or any values that we cannot use. X minus 3, x minus 5. So, as big and nasty as this looks, you notice the way that most of this drops out. I got 3x minus 15 minus 6x plus 18. It's a minus 6 times x minus 6 times minus 3. I got an x minus 10. So let's go ahead and go. At this point, it's solving an equation. Now, here's the thing about these. 13 over 2, that is not 3 or 5, nor is that an answer that I could have just guessed. Does it look like I made a mistake somewhere? Nah, looks like we're good. Okay, definitely if you're going through these and you see a mistake that I've made, let me know. Sometimes I can't talk and think at the same time. So I got x plus 5, so x cannot be negative 5. That x squared minus 25 means that x cannot be positive 5 either. So I got x minus 5 times x plus 5 minus 50, x minus 5 times x plus 5 See? Talking. 6. X minus 5 times x plus 5 is x squared minus 25. I'm just going to go ahead and do that there because nothing's going to cancel on that one. So these cancel. These cancel. I get x squared minus 5x minus 50 minus 6x squared plus 150. I got minus 5x squared minus 5x plus 100. I'm going to factor out that negative 5. I really am not a fan of my leading coefficient being negative. I want a positive one. We got x plus 5, x minus 4. So x equals negative 5, x equals positive 4. We know from up top here that x cannot be negative 5. So our sole solution is x equals 4. Now, solving the literal equations down here. Let me change color. If I want to solve for I, here I need to get I out of the denominator. I'm going to multiply both sides by I, and then I'm going to go ahead and divide by r. Okay. Don't overthink. If it helps, or sometimes it helps, to plug in numbers and solve it that way. Because we seem to be a little more comfortable when we're using numbers. This third one here, we want to solve for p. I'm going to start by getting rid of the w. So I got L plus W equals P over 2. To undo the divide by 2, we multiply. I got to multiply this whole side. I get P equals 2 times L plus W. Hopefully you recognize that as the formula for the perimeter of a rectangle. Do we need boxes? Okay. So this one's a little more involved. P equals A over 1 plus RT. We want to solve for T. So we are going to start by multiplying both sides by 1 plus RT. I want to solve for T, I got to get it out of the denominator. And I'm going to go ahead and multiply through because I have to isolate T, which means I need to get it out of the inside of those parentheses. I'm subtracting P. And then I'm dividing both sides by P times R. And so T is going to equal A minus P all over P times R. Now notice I cannot cancel those P's because in the numerator I've got a subtraction separating those, and I could only factor the P out of the second term and not the first. If I can't factor it out of everything, I don't factor it out of anything. Okie doke. I am going to start by clearing both denominators here, 2 minus x, 2 minus x. Also going to cram the 3 in there. So I got both pieces at the same time. We want to solve for x, which means I want x by itself. So I am going to, I really want it to be positive as well. So I'm going to move the 4x over here. And I'm going to subtract the 3y and the 15. 4x equals negative 3y minus 7. I'm going to divide everything by 4. And I get an x equals negative 3/4 y minus 7/4. Okay. We have got a 1 over r equals 1 over r sub 1 plus 1 over r sub 2. We want to solve for r sub 1. And as much as we would like to just separate everything out, we really can't. I can't just flip everything over because I've got an addition on the right-hand side. So I'm going to go ahead and I'm going to start by multiplying everything by r and r sub 1 and r sub 2. And this one I'm going to go ahead and write out so you see what it looks like. R sub 1, r sub 2, all over r sub 1, and r sub 1, r sub 2, all over r sub 2. I'm going to cancel what I can. I'm going to rewrite. This one's got an r sub 1, r sub 2. I got an r and an r sub 2. And I got an r and an r sub 1. Now, since I want to solve for r sub 1, I need all the r sub 1s on the same side. So I'm going to subtract the r times r sub 1. I'm going to factor out my r sub 1. And then I'm going to go ahead and divide. And I'm going to really, we'll see if this goes onto the separate page, whatever. I'm going to divide both sides. That is not what I wanted to do. By r sub 2 minus r. Cancel, we get r sub 1 equals r times r sub 2 over r sub 2 minus r. Sorry, that one's kind of messy, but I'm going to leave it there. Last one, we want to solve for b. We're going to kind of do the same thing. We're going to multiply by ab. I get ab over a plus ab over b equals ABC. The A's cancel here. The B's cancel here. I'm going to subtract A from both sides. And if you want to factor out that A and B, oh, wait. No. Back the truck up. Can't leave it like that, can I? We are going to subtract the ABC. And then we're going to factor out the B. Like I said, really similar to what we just had. And then we're going to divide. And B equals negative A over 1 minus AC. If I want to multiply top and bottom by a negative, I can go A over AC minus 1. Exact same thing. I crammed in a lot on that page. So we are going to just visually divide a little bit.